Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss on our second machine learning project. Yeah, it is on a linear regression with the SGD project, and it is on vehicle performance prediction. Dear friends, this exact project focuses on leveraging machine learning, specifically regression analysis, to predict vehicle performance in the automotive industry. While many companies in the sector are investing in machine learning for marketing, only a few are implementing it more broadly within their operation, incentivizing its use and trying it to key performance indicators. So this gap highlights the need for a deeper commitment to not only developing machine learning capabilities, but also ensuring their effective integration and utilization in business processes. The central objective of this project is to use a regression model to predict a key performance metrics as like vehicle mileage, represented by kilometer traveled per liter. Accurate mileage prediction is essential as it provides critical insights into vehicle efficiency and helps automotive company optimize design and improve fuel economy and meet regulatory standards. Dear friends, in turn, this data-driven approach to vehicle performance prediction can empower automotive companies to make smarter engineering and business decision. So moving beyond marketing to operationalize machine learning across departments by developing a reliable predictive model, mainly this project aims to contribute to the automotive sector's shift towards a more integrated, data-driven approach where machine learning plays a critical role in operational excellence. Let I just share this problem statement, and of course kindly just observe the exact data definition. Dear friend, of course, today in this session we are just going to discuss about mainly on not only SGD, of course we are going to discuss about ordinary least square, and let me just compare both the model and identify which one is best. And we are not going to stop there. Of course, we are going to include the one more important point. What is the performance, or what is the parameter to be done to improvise the other? So don't forget to continue till the end. So yes, don't skip the videos, follow step by step. Dear friends, of course you all know, so first we import essential library that will facilitate our data analysis and visualization task. We begin with importing pandas for data manipulation and analysis. Next we import NumPy, which supports for large or multi-dimensional arrays and matrices. And yeah, we also import SkyPy stats, actually which offers a wide range of statistical function. For visualization we are using Matplotlib, and of course you can also use Seaborn, and the latter of which is built on top of Matplotlib to provide a more user-friendly interface for creating attractive statistical graphs. And yes, let me just enhance our visualization. We set the default aesthetic of Seaborn with SNS.set. Okay, this ensure our plots are visually appealing right from the start. Okay, and yes, dear friends, next we handle warning by importing the filter warning, the function from the warning module. So using a filter and warning and ignores. And yeah, this prevent warning messages from cluttering our output, allowing us to focus on the analysis. Okay, and next yeah, we then set the plot size globally by modifying the RC param of Matplotlib. So this exactor specifies that all forthcoming plots will have a width of 15 inches and the height of 8 inches, ensuring consistency in our visual presentation. So let I execute that. And next one, yeah, lastly we adjust the display option for NumPy. Okay, and we set this set underscore print option. Actually, this just suppress the scientific notation for floating point numbers, making our output more readable. And similarly, we format the display of a floating point number in pandas by using this .2 format. Okay, so only 2 decimal places. And let I execute, and we are going towards the analysis. Yes, dear friends, we begin our data analysis by loading the data from loading the data into Panda data frame. To do this, we utilize the read underscore CSV. And of course, the functions from the pandas library. And kindly just observe here we have, this is the our data.csv. Okay, and here it just got loaded. Okay, and this R, before the string that indicates a raw string, ensuring that any special characters in the file path are treated literally. And dear friends, once the data is loaded, we take a look at the first 5 rows of the data set to understand its structure and the information it contains. And this is done by this head. And kindly observe, dear friends, we have the horizon, cylinder, displacement, horsepower, weight, acceleration, year of the car, manufacturing, name, and kilometer per liter. Okay, so to maintain our integrity of the original data set while allowing for modification, we create a deep copy of this raw data by using this command. This ensures that any changes made to the data or data frame do not affect the raw data, that is preserving the original data set. And let me enter into the analysis. And kindly just observe, dear friend, here what we are going to do here. And yes, this data preparation is a crucial step in the data analysis workflow, as it involves cleaning, structuring, and integrating data to ensure it is ready for analysis. So first of all, let me just check with the dimension. We just go for data correction if anything is needed. And let me just have a summary, the statistical summary. And last, we just check for any missing values is there. So in such a case, first of all, let me just check dimension and data types of the data frame. And dear friends, we just start by examining the dimension by providing the data.info, and kindly just have a note onto this. This step is essential for identifying any potential issues with the data type that may affect our analysis. Okay, so yes, kindly just observe. First of all, we have 398 entries. That is the observation. And of course, 0 to 397 is the one indexes. And origin, it just specify integer. Cylinder, it is also the number of cylinders, that is integer. Displacements comes under float. Horsepower, okay, actually horsepower is in object. Okay, so it not should be. Okay, so yes, we have noted one thing. And let me just see weight, it is an integer. Float, acceleration, it is in float. Year also integer. Name, of course, name of the manufacturing, all the things, it comes under object. And the kilometer per liter, okay, it is in float. Okay, now of course we have one ordinals related to that data type. Yes, of course, let me have one more time about the size. Yeah, we have 398 entries. Okay, and with that we have 9 columns including the task. or the target. And upon reviewing the output of our preliminary data analysis, we observe that the horsepower variable, which should be a numerical attribute representing the power output of the vehicle engine, is incorrectly identified as a categorical variable. This classification is invalid as horsepower is inherently a continuous numerical value. And kindly just examine, dear friends, here when we just go towards this, I want to have check on towards those missing values also. Yes, we are going to correct this horsepower. Let I check any other null values is there or not, and we go for missing values to be checked. Okay. So yes, upon inspecting this, we find that there are no missing values present. So this is a positive outcome. The absence of missing data simplifies our analysis process. Okay, now here, yeah, we can proceed with the confidence that we don't have any missing data. Okay, now our main thing is towards a correction of data type. And of course, dear friends, after reviewing the dimension and the data type, we went for the horsepower that it specifies as like there is something maybe may include correcting some typographical error or standardizing format and ensuring that categorical variable are appropriately labeled. So proper data correction is vital for maintaining data integrity and ensuring accurate analysis. So let me just check what is the exact type it is specified. Of course, here the horsepower, it is an object. And yes, as we continue our data preparation, we notice that horsepower column is currently classified as an object rather than a float. So despite the variable visible this numerical value, this misclassification can hinder our ability to perform numerical analysis and visualization effectively. Okay, now let me check, have a look on towards before making this conversation as like object to float. Let me check. It's prudent to first examine the unique element within the horsepower column to identify any discrepancy that may be causing the misclassification. So by checking for this unique, let me identify here. Yeah, there is a question mark. Kindly just see the mark. So we can spot a non-numeric entry, that is even any unexpected string or formatting issues that need to be addressed prior to conversion. So here, of course, upon examining the unique element of the horsepower column, we discover that is a character question mark is being used as a placeholder for missing value. So this representation can lead to issue when we attempt to convert the column to a float type, as it prevents the accurate interpretations of the numerical value. So let we have a count also is whether it is present once or more than once. Okay, it is just in the side the values. Okay, of course we are not able to take. Okay, anyhow, let me just remove that. Before removing, I want to know how the process can be done. See, to address this issue of this question mark, that is the placeholder in the horsepower column, we will proceed with removing their entries from the data set. We will achieve this by utilizing the pandas. Of course, you can also make use of replace method, which allows us to replace the occurrence of this question mark with NaN or any other functionalities. That is wrong. This will not only remove the invalid entries, but also mark them as missing value in the data frame. And subsequently, we can also use the drop NA method to remove any rows that containing missing values in the horsepower column if we choose to do so. But let we make in another format. Kindly just see here. we are going to extract only the data that is not equivalent to this question mark, not equivalent towards this exact symbol. You can have it. So here we are going to create a new data frame that retains only those rows where the horsepower value is not equal to this symbol. Okay, it is done. Now next we need to verify whether this question mark value remains in horsepower column. So we can do this with this particular expression, and let me just see what we get. Yeah, we returned, actually we just got it as like false. So there is no question mark entries left. Okay, now let me just check with the shape here. So it specified 392 entries. That is the observation here. It is 392. Okay, kindly have a note on towards it. We are just going to discuss it further related towards this number of data. And yes, dear friend, after ensuring that the column is free of this placeholder, yeah, we proceed to change the data type of the horsepower column to float. And yeah, here we use this code snippet to change it towards the float. And yeah, dear friends, even you can just have a check. Okay, now what is the float? Okay, yeah, the horsepower, now it is in float. Okay, super. And before going on to that, of course, dear friend, kindly just see here, we now we turn our attention to prepare the categorical future in our data set. See, each categorical feature requires different handling to ensure they are appropriately represented for analysis. And mainly here we want to see on towards three features. The first one, it is all about model year. See, model year is considered as ordinal variable as it represents the age of the vehicle in a ranked order. So therefore we maintain in the same thing integer. Okay. So next one, it is origin. The origin column represents a true categorical variable that indicates the geographical origin of the car. And since categorical variable need to be transformed into a format suitable for machine learning model, we will one-hot encode this column later. Kindly just have a note on towards it. And next, it is all about name. So the name column contains two important pieces of information. That is the car's manufacturer and its model. So to make the data set more informative, we will split this column into two new columns. One for the manufacturer and another for the model. So this transformation allows us to analyze, okay, these attributes independently, providing greater clarity and utility in our analysis. Okay, further moving on. So let me refine our data set. So we create a deep copy of our original data frame for modification. So here we go. And next we convert this origin column to an object type. So this designation reinforces that origin is a categorical variable, setting that stage for one-hot encoding. Okay, and yeah, here we have the data. Okay, so yes, we can examine the structure of our data frame by using this head method. Okay, so providing a glimpse of the first few rows to confirm our changes, what we have done. Okay, so here we just, and yeah, the next one, to extract useful information from the name column, we employ this split function. Okay, and here I'm just using the first, that is n is equal to 1. Here I have specified this as like the first space, creating new column, one for car's manufacturer and another for model. And here this n is equal to 1 parameter ensures that the split occurs only at the first space, allowing us to capture the complete manufacturer name while isolating the model. So let us execute it. So after splitting, we again have a check on towards this, And yes, dear friends, kindly just have a look, the verifying of two new column added. So that is manufacturer and towards model. And yeah, subsequently we drop the original name column. So as it no longer needed, and I just drop it. Even you can just have a check on towards the first few rows, and here I have just specified the transpose of it. So kindly just observe, here it is the horsepower, weight, acceleration. Okay, here we just got the manufacturer and to the model. Okay, now let we have one more thing, dear friends. Actually, see, after splitting the name column into this manufacturer and model, we proceed to examine the unique manufacturer present in our data set. Okay, so let me just have a unique, and of course it's in a shortened manner. Okay, so upon inspection here, kindly just observe, we notice several errors. Yes, the first line, so Chevrolet, so here also we have, there is a misspelling, and here Volkswagen, and kindly just to see here, there is Mazda, both the things as like the spelling is there, erroneous entries is there, and of course we find a synonymy and abbreviation like VW maybe, which should be standardized to Volkswagen for consistency. So yes, to ensure the integrity of our data set, we will systematically correct these erroneous entries. See, for instance, we can replace this wherever this Volkswagen is there. Okay, we can just replace with the correct spelling, and we can just make this with the correct spelling as mentioned. And for this VW, again we can just replace it. By implementing these correction, we not only improve the quality of our data set, but also facilitate more reliable analysis and insight moving forward. And dear friends, to address this discrepancy identified in the manufacturer name, we are going to create a dictionary here, okay, and which we just called it as like errors, and that maps the incorrect entries into the correct form. So this is the incorrect, and I just want to replace it with this. And yes, dear friends, using this mapping, we apply the correction to the manufacturer column, and once this exact map function that replaces any matching key in the manufacturer column with the corresponding values from this error. Okay, that is error dictionary. And this approach effectively standardizes the manufacturer name in our data set and enhancing its quality and ensuring consistency. See, as a result, our analysis will be more reliable and interpretable, as all manufacturer names are accurately represented. And here one thing I just want to specify, fill NA, this exact method ensures that the original value remains unchanged. So let I execute it. And yeah, once again, let me just have an insight into the data distribution of manufacturer within our data set. So yes, these are the one. Okay, we are having a great data list. Okay, yes, dear friends. So now let we just conclude our review of our manufacturer column and ensure that all correction has been applied effectively. So we will print the shorted list, okay, of unique manufacturer, and kindly just see here. Kindly just see here, and of course, dear friend, here as we dwell deep into the model names within our data set, we notice that some entries appear to be redundant or incorrectly formatted. Yes, of course, there are few. And while handling checking each model name for accuracy, that would be far too time consuming. So we can streamline this process by adopting a brute force approach, that is removing all special characters from the model names. Okay, so let me just first of all check what is that. Let me have a length of it. So it's specified 296. Okay, so let me just eliminate any unwanted symbols or any punctuation or formatting issues that may dissolve the model names. Okay, so here for that what we are going to do is, by utilizing an regular expression method, okay, regular expression or this string manipulation method, we are going to replace any special characters with empty string. So this will allow us to retain only the alphanumerical characters in each model name. And okay, now let me have a view and kindly just observe. Okay, so now after clearing the model by removing special characters, we want to access the diversity of model entries in our data set. Okay, now we have the count as like 293. And dear friends, with this our data that is preparation effort has been completed. So we can confidently describe that is the data set and its current state. Okay, after systematically addressing issues such as errorness, manufacturing names and cleaning the model names of these special characters, our data set is now in good order. Okay, now let me just move on to have a statistical summary and kindly just observe this. Okay, so now we are going into discuss onto this analysis of our data set. So it essential to examine the summary statistically for both numerical and categorical variable. So this exact describe the method, okay, would just gives defaultly only for numerical feature. And observe, dear friends, the cylinder, okay, when I'm just making this describe, of course, we just generate a comprehensive output of the key statistics as like mean, median, minimum and maximum and standard deviation. So here when coming towards the cylinders, yes, minimum it is 3 number of cylinder, maximum it has 8 number of cylinders with of core. And here we have a median of 4, okay, and we have a mean value of 5.47. And when coming towards displacement, minimum 68, maximum 455. And horsepower, minimum 46, maximum 230. And weight, it is 849. Here it is 5140. Acceleration, okay, the minimum it is 8. Sorry, I'm just speaking here. It is 1613 and here it is 5140. And kindly just observe this one. Yes, we have the minimum, the manufacturing year, that is 1970 till 1982, and kilometer per liter it is of 3.83 to 19.81. And one thing observed, dear friends, here each and every unit whichever it is specified is different from each other. So of course there is a need of scaling functionality, so that one we have to keep it in mind. And yes, when on just going towards the categorical data, okay, we have to include that object, and here we have only 3 categorical data. One is origin, manufacturer and model. Okay, and taking it into the account, the topmost origin, it is here we have 3 unique origins is that, and manufacturer totally we have 30 manufacturer, and models of course we are just taking it into account as 293 uniqueness is that. And towards the top frequency we have the manufacturer in 4. Okay, so these are the exact informations once we had on a statistical summary. Okay, now next let me just explore further by making an exploratory data analysis. So before going on towards analysis, I just want to have a visualization effort of each feature. So yes, as we have discussed, the cylinder, it is minimum 3, maximum it is going towards 8. And here you can just have a look, the number of cars which has the cylinder 4 is the one highest. And when coming towards displacement, yeah, we are able to see as, yes, there is a skewness is there, and horsepower, of course, we have a skewness. And yes, of course, this histogram, it just shows the data distribution. And yeah, when on just just examining the weight, of course, it is also a skewness. Yeah, we have a normal distribution in the acceleration and uniform distribution in the year, and skewness with kilometer per liter. Okay, now we have an analysis towards this univariant. Okay, in our univariant analysis, we examine a particular numerical variable in our data set. So here, let we just first of all have the kilometer per liter, okay, the exact data. And yes, kindly observe, dear friends, the minimum value of this variable here, it is 3.8, and the maximum value, it is 19.81. Okay, so this indicates a range of values that this variable can take, highlighting the extent of variability present in our data. And interestingly, the average value is 9.97. That is suggesting that is the average, the observation tend to cluster around this midpoint. Okay, so here our midpoint 9.67. Okay, so however, the variability is not noteworthy. Okay, so with the standard deviation, we have 3.32. Okay, so this variation indicates that while many observation are around the average, there are significant difference among the individual value. So which could suggest the presence of outliers or a diverse set of observations within the data set. Let me just have a view of that. Of course, already we have done it, but anyhow, let me make use of this density. Yeah, there is a slight skewness can be viewed with this smooth kernel density estimation. And dear friends, of course, we can visualize this by using the QQ plot, where this compares the quantiles of our data against the quantile of our normal distribution. Okay, so let I just execute it. Okay, once again, yes. So yes, upon reviewing the plot, we observe that while some data do align well with this red line, okay, there are noticeable deviation, particularly in the tail of this distribution. So this indicates that our data may not fully conform to a normal distribution, as evidenced by this presence of the skewness or outliers. So anyhow, let me just check whether there is a skewness. Yes or no? Of course. So yes, if we want to gain a deeper understanding of distribution characteristic, yes, of course, it is mainly important to know what is the value of this skewness and kurtosis. Of course, it is important statistical measures too. Okay, and of course, when on viewing this, yes, the skewness measure the asymmetry of the distribution. And kindly just observe, dear friends, a skewness value of 0 indicates a perfectly symmetrical distribution, and a positive skewness suggests that a right tail of a distribution is longer and fatter than the left, while negative skewness indicates the opposite. And here, of course, we have positive skewness, slight positive skewness is there. And when coming towards kurtosis, yes, on other hand, this measures the tailedness of distribution. Okay, tailedness of distribution, and kurtosis value of 3 represents a normal distribution. And here value greater than 3 indicates a distributions with heavier tail, but of course, while value less than 3, that is ours, kurtosis is less than 3, which it suggests a tailor, a lighter tail we have, though it is a platykurtosis. Okay, yes. So now here we are able to understand that we don't have a normal distribution. And to address the non-normal distribution of this kilometer per liter variable, we apply a log transformation. And kindly observe, dear friends, this transformation can help stabilize variance and normalize the distribution, so making it more suitable for statistical analysis. Okay, so let me just here create a new functionality, and I just want to make it a deep copy to data 2. So where we store the natural logarithmic of this kilometer per liter column. Okay, and yeah, here we have created a new log mileage column. Okay, so to have a estimation of what is the log of that particular variable. And let I just first of all create it. Yes. Now let me just have a view on towards this data. Okay, so here we just got the log mileage. Actually, dear friends, this exact value, even we are able to see this log value. Let me just visualize the distribution of log transformed value. So let I just have a distribution here, and now observe. Okay, so the exact log transformation has affected the distribution. Of course, you are able to see this, and anyhow, I just make a small scroll above. See here, this is what our original, and once after making the log transformation, yeah, nearing towards normal. Yeah. Okay, fine. So additionally, we already generated the QQ plot. Okay, let me just access the normality of this log transformed variable. So here in this QQ plot, kindly just observe. Yeah, we expect the data points to align closely with the red reference line, so which represent a normal distribution. And yes, we note deviations, any deviations from this red line. Now observing the tail of the distribution, it just revealed that a transformation that is sufficiently normalized the data. Yeah, good. Okay, so after applying the log transformation to the kilometer per liter variable, the visualization results, that is, we can conclude that log transformed mileage now represented is actually, it is a normally distributed. So the distribution plot indicates that logged transformation value exhibit a bell-shaped curve. Of course, the characteristic of a normal distribution. Now let me just go towards distribution of displacement. Dear friends, engine displacement is a critical measurement in automotive engineering. So defined as a total volume of all the pistons inside the cylinder of a reciprocating engine during a single movement from top dead center. Actually, it is specified as like a TDC, and to bottom dead center, that is BDC. Okay, so it is a key factor in determining the engine's power output, efficiency, and overall performance. So understanding the distribution of this displacement variable in our data set that provides insight into the type of engines that are represented and how they correlate with other performance metrics, such as horsepower and fuel efficiency. So yes, let me just first of all have a look on towards this. Okay. So yes, kindly have a note. So the minimum value of this displacement here, it is specified as like 68, and the maximum it is 454, so 55. And when on just taking towards the mean value, it is 194, where the variance, that is standard deviation, it is 104. And kindly observe, dear friends, the mid value, that is the median, it is far away from this mean, that is here it is 151. Okay, fine. Anyhow, let me just have a view of this distribution plot, and let me have, okay, kindly just observe, dear friend, this exact distribution, it just shows actually it not as a normal distribution. Okay, so this insights, such insights are essential for accessing how displacement may relate to the other performance metrics, including the horsepower and fuel efficiency, which I have just specified previously. So kindly just have a note, this particular data when on just making towards this displacement, it is very much important. Okay, so here the revealing the range, and here towards the central tendency of the engine, that is sizes within our data set, and kindly observe here the exact distribution, how it is, whether it seems to be a bell curve. No. So let me just examine it again further, and before moving on to that, let me jump on to analysis of cylinder. And dear friends, this analysis of cylinder, so let me just understand the distribution of engine cylinder in our data set. We utilized a count plot. Okay, so let I just have the count plot. Okay, so here, of course, we have seen this in the histogram. Yes, from resulting this count plot, we can clearly visualize the distribution of vehicle. That is, the most common configuration is the cylinder 4, which has the highest count among all categories, and approximately 98% of the vehicle in our data set are equipped with this 4, 6 and 8, indicating a strong preference of their configuration, okay, among the sample. And conversely, with this 3 and 5, the cylinders are relatively rare, representing only a small fraction of the data set. Okay, yes, fine. Now let me just move on to the next one. So yes, of course, from the above we have already seen. Okay, so these are the exact data, and yes, cylinder, it is a categorical, so but it is in specified in a numerical value. Okay, so we have to change that. So that exact value, of course, kindly have a note. We want to have a copy of a deep copy of that, to not modify or to not disturb the original data. Okay, so let me just have it and change it. So now the exact cylinder, so it is recognized in a object type in the data set. And kindly just let me have this data, and yeah, we have one more thing is there. Yes, 392, it's still there. And rather than specifying that about this data integrity, now it is in object type. Of course, everything now here it is in 392 only. Okay, now yes, of course, exactly, dear friends. So here when on just viewing this, now the attribute is in object. So now let me move on to analyze about the model. Yeah, the exact model number here. Let I just have a count plot here. And the maximum, it is 1973. Yes, okay, yeah. The maximum number of the vehicle in our data set corresponds to the year 1973, indicating that this model year was particularly prevalent among the sampled vehicles, and conversely the minimum number of this vehicle is recorded for the year 1974, I think so. Okay, even this is lesser. Okay, here this is 1974 is the one, so suggesting that is few models from these years were included in our. Okay, so this distribution of model year can provide valuable insight into the age and the vintage of the vehicle represented, okay, as well as potential trends in manufacturing and consumer preference during these years. Okay, now let me just move on to the origin. Okay, so analysis of origin. Yes, dear friend, here let I just make a count plot again. And yes, it is with three categories. Okay, here this origin, which represents the geographical region from which the vehicle originated. And yeah, the majority of this vehicle in our data set are from this region 1. Okay, so highlighting a strong prevalence of car manufactured in this area compared to the other region 2 and 3. Okay, so which contains only fewer vehicle, so indicating only lower representation in our sample. Okay, so this is how. So kindly just have a look. Now let me just move on towards the horsepower. Yes, dear friend, let we have again the distribution plot. This is what we are going to consider it now. Yes, the majority of this vehicle in our data set exhibits horsepower rating concentrated from here. It is 50, and this is mid, so here it is 75. So okay, so here let me just have, this is the exact normal distribution. So towards this normal distribution, I have to concentrate around 75 to 110 horsepower range. So this suggests that a significant portion of the car are designed for moderate performance level, likely balancing power with efficiency. And yeah, conversely, only few possession horsepower rate exceeding this 200. Okay, so that is also make an impact here. And let I just move with yeah, okay, here it is already specified. Okay, now let me just move on towards analysis in manufacture. Okay, so yes, dear friends, we are going to discover it which a rich diversity of vehicle manufacturing represented in our data set. So I just include one among the functionality. Okay, so it just gives a big tabulated formation. And here our data set which contains the vehicle, let I just travel it first of all. So what we have, okay, so totally cars from 30 manufacturer, and here we are just going to have only the list of top 10. Okay, and among this top 10, the how many uniques are that? Of course, there are so many unique categories, and here from 30 manufacturer we are having only the top. Here it is listed, and one is Ford, another is Chevrolet. Okay, so that is the one which we have highest. Okay, good to have a view. And yeah, dear friends, this output reveals which manufacturer dominate our data set. And of course, here our domination, it is related towards the Ford and Chevrolet, that is offering insights into market, that presence and brand popularity. Okay, and additionally we visualize the distributions also, and here from the bar chart we can observe the count of vehicles associated with each manufacturer. So this visualization emphasizes the top manufacturer, showcasing their market share relative to other in the data set. Okay, so overall this analysis provides valuable insight into the automotive landscape represented in our data set, that is reflecting trends in consumers' choice and manufacturer prominence. Okay, yeah, let me just examine about the model. So yes, dear friends, here also we are just going to make use of the same tableau to have that models, and in this, yeah, the top model, 10 models we have listed, and we had a bar chart related towards it. And here the table showcases the lead model insights, offering insights into consumer preference and the popularity of the specific vehicles. And one is Rabbit and Pinto. And yes, here the bar chart provides a clear visual representation of the count of vehicle. Okay, so count of vehicle associated with each of the top model. And one more thing here, I have just given an the rotated one. So the optics also I have just given also 45-degree. Okay, so to make it clear and visualize it, so that is what we are able to see, what are all the cars and model name. Okay, now next let me just move on towards multivariant analysis. Yes, dear friends, in our multivariant analysis, we explore the relationship between kilometer per liter and horsepower to understand how engine performance impact fuel efficiency. Okay, and let me just have it and kindly just observe. So as horsepower increases, okay, horsepower increases, the kilometer per liter trends to decrease. So this inverse relationship suggests that vehicle with higher horsepower may consume more fuel, leading to lower fuel efficiency as measured by KPL. So this findings aligns with our expectation, as more powerful engine typically requires more energy to operate. Yeah, which can result in increased fuel consumption. So here the visualization effectively illustrate this trend, allowing us to grasp the dynamic between engine performance and fuel efficiency. Okay, now let me just have a multivariant analysis with this kilometer per liter with weight. Okay, so let I just have a view and kindly just observe here. Yes, generally as the weight of the vehicle increases, the kilometer per liter trends to decreases. So this suggests that heavier vehicle often struggles to achieve higher fuel efficiency, as more energy is required to move a heavier mass now. So yes, let we move on to the next one, multivariant analysis on KPL with acceleration. So let me just have the view and kindly just observe here. As acceleration increases, there tend to be a variation in kilometer per liter value. That is, in many cases, higher acceleration may correlate with lower fuel efficiency, indicating that vehicle designed for faster accelerator might consume more fuel. That is what here it is specified, that is there is a linearity. Okay, yes, now let next we just go towards KPL with displacement, and kindly just let me have a view on towards it. Okay, so yes, generally a displacement increases with observe a tendency of KPL to decreases. So this suggests that vehicle with large engine displacement often exhibit lower fuel efficiency. So kindly just observe, dear friends, this relationship can be attributed to the fact that larger engine typically consumes more fuel due to increased power requirement. As displacement rises, the engine has a greater capacity to burn fuel, which may result in higher fuel consumption and consequently lower KPL value. Okay, now let me just move on towards the cylinder. Okay, KPL with the cylinder, and of course we all know the cylinder 4 is the highest number, and observe we are viewing it in the box plot, and yes, here we are able to see that is the highest mileage or gallon, that is the MPG, okay, indicating that these vehicles tend to achieve better fuel efficiency compared to the other. That is the four cylinder variable. And notably, the data shows that a significant portions of vehicle in our data set are equipped with this 4 cylinder, which may contribute to be the observed trend in mileage. Okay, now let me just have a view of KPL with year, that is the model of year, and let I just have a view, and here. Okay, so with each passing year and particularly with the newer model, that is the mileage per gallon MPG tends to increase. This suggestions that manufacturer are continuously improving fuel efficiency. So there is an increase. Excuse me. So there is an this is the exact increase, and this suggests that manufacturer are continuously improving fuel efficiency in their vehicle design. Okay, so let me just have that in our point. And coming towards the covariance. Dear friends, covariance is a statistical measure that indicates the extent to which two variables, such as here assets returns, change together. And it is particularly useful in finance for assessing how different assets behave in a relationship to one point. And here I just want to specify one thing. Let me just see the exact view. Yeah, here we don't get any particular functionality, and I just specify one thing, dear friend. A positive covariance indicates that assets return move in the same direction, and when conversely a negative covariance significates that assets return move in opposite direction. Here we have of course when we just having towards the weight, of course kindly just see here understanding the covariance which is essential for investor when constructing a diversified portfolio, as it helps to assess the potential risk and return of combining different assets. So by evaluating the covariance among various assets, investor can make more informed decision to achieve their desired investment outcome. But here we are making it towards car and car manufacturing. So now let me just go towards thing, and yeah, we just have a calculation of correlation. Yeah, dear friends, here correlation is a statistical measure that expresses the extent to which two variables are linearly related. I just have a view on towards it. Yes, it provides an insight into strength, not only that, and also direction of the relationship between that variables. And one thing I just want to specify it, one important thing, dear friends. See, actually, a correlation coefficient of 1 that indicates a perfect positive correlation. And if the coefficient of -1 indicates a perfect negative correlation. And if the coefficient of 0, that suggests no correlation. So let me just have the correlation output. So see here. So yes, there is a negative impact, and here it is also where there is a negative impact, and only towards the year and on towards acceleration of the vehicle has a positive correlation. Okay, so the resulting correlation matrix that displays the correlation coefficient of all pair of numerical variables in this data set. And here, yes, dear friend, identifying strong relationship, potentially redundancies and insight that can inform further analysis and model selection. So now let we implication of this correlation analysis in future selection. Okay, so before, let me just have a view on towards positive functionality between the futures. So here we have the futures. Okay. So by analyzing this correlation matrix, yeah, we can better understand how variables interact with one another. Guiding decision making in areas such as future selection, risk assessment, and investment strategy. And yes, here also we are just making it towards the acceleration on towards the year. Okay, now let me just go on towards this implication. Here I just want to have this weight, displacement, manufacturer and model has to be deleted. That is dropping this highly correlated variables. Okay, so these are the exact highly correlated variables I just want to remove. Why? Because see, actually when we have a strong positive correlation, yes, the high correlation coefficient among these futures suggest redundancy in the information they provide. And when coming towards this recommendation also, there are so many things as like recommending towards multicollinearity and recommending towards overfitting risk and interpretability. Yeah, we need to drop this. Okay, so let me just have cleaned data and kindly observe. This is what our data, that is cleaned info. Okay, so we are having 8. So what are all the columns? We are just having it in our data. It is as like origin, cylinder, horsepower, acceleration, year, kilometer per liter, and lastly the log mileage. Okay, yes, and one thing here I just want to specify from the beginning, we have seen a small deviation in this entries, that is 392. Because here indexes it is 0 to 397. See, actually this often occurs when rows are removed or filtered out. Okay, resulting in this non-contiguous indexes. That is often happens, so don't get worried. So yes, let me next go on towards label encoding of categorical data. Dear friends, after cleaning our data set by removing this highly correlated and unnecessary categorical features, we now turn our attention to encoding the remaining categorical variable. And in our cleaned data, it is essential to convert categorical data into a numerical format that machine learning algorithm can interpret efficiently. Okay, so yes, by using this function, that is get dummies function, we are going to utilize one hot encoding. Okay, so yes, we are making it here this drop first true, which we avoid the dummy variable trap, which can lead to multicollinearity. That is also we are just doing it. And let we have our resulting data here, and kindly just observe, these are the exact data, that is after one hot encoding. Okay, so this is our resulting data frame. So now contains only numerical values with each categorical variable represented by its respective binary columns. Okay, now let me just standardize. Of course, in the time of describe itself, we just specified that each and every data are having a in different scaling standards. So surely there is a need of scalar functionalities or standardizing the data. So yeah, that we are here towards this point. So to prepare our data set for machine learning model, it is important to standardize the future to ensure that they are on a similar scale. Okay, so yes, in this case, we use minimax scaling, which is also known as normalization. So, which transform the future to a range between 0 to 1. Okay, so let I just import the minimax scalar from the sklearn pre-processing module, and yeah, prepare the future here, and we drop the exact unneeded, that is the target variable, kilometer per liter and log mileage variable from our data set, since we want to scale only the future. Okay, so we are dropping that. Okay, so kindly just see here, let me just have a view of this X data. So these are the exact data once after removal. And yes, dear friends, here we are going to make or initialize the scalar and fit it into our future set. Okay, so this one we are fitting the model, and next let we transform the future, that is we apply the scaling transformation to the future set here. And what is the exact future? Let me just have the view of X variable, that is the standardized future. The X contains standardized future set, and let we transform the exact prepare the target variable also. Okay, so we assign the log transformed mileage, the mileage here. Okay, and yes, dear friends, here this y that holds the target variable. Okay, so this is what. Okay, now let me just build a robust machine learning model. So it is essential to evaluate its performance on unseen data. So this is typically achieved by splitting the data set into two subsets. One for training the model and the other for testing its predictive capabilities. Okay, so let I just make it, and kindly just observe here we specifying 20% of data that to be reserved for testing data, and set a random state to ensure reproducibility. Okay, so by using this, let me just have a look on what are all the X train data and X test data, and this is Y train data and Y test data. And yes, dear friend, here this random state 10 is being set, which is typically done to ensure reproducibility with when splitting the data. Okay, so actually it is in splitting the data into training and testing. And here we are just going to make it for consistency and significant difference. We want to check it, and kindly just have a note on towards it. It is 2.25 and 2.10. That is this exact is specifying about the mean value. The mean value of the Y train data and Y test data. Okay, let me just discuss it further, and even before that, let me apply it on towards the model. Now, building a linear regression model using ordinary least square. Why we are just going for ordinary least square? Yes, first of all, let me just build it here, and then we compare towards the SGD. Yes, building the model, we will use this linear regression classes from sklearn, okay, model, and to create our regression model. Okay, so here we are just going to initialize the model and fitting it to our training data. And let me just predict the value. After fitting the model, we will use the predict value of the target variable for our testing data. Now let me compute the accuracy. Before that, let me just have a view of the plotting X and Y. Okay, so these are the exact X and Y. Okay, now let me just compute the accuracy measure, and yeah, to evaluate the performance of our model, we will compute several accuracy metrics, that is common metrics for regression models. that is including mean absolute error. Okay, here we have specified the R squared, adjusted R squared and RMSE value. So we will utilize the relevant function from SQL matrix, okay, to calculate this. And once done, let me just have a view of a tabulated manner. So I just want to show you the tabulated manner, that is, this is the OLS model and this is R squared of OLS, adjusted R squared and RMSE value. Okay, now let me apply the same thing and we want to make it towards SGD regression. Okay, so let me just apply this on towards SGD, the same thing, but here we are making it with a max iteration. Kindly just observe here, dear friends, we are making it towards iteration of it is 1 lakh iterations. Okay, so let maximum number of iteration for the optimization, and let me just fit the model. And yes, once done, let me pass us towards the prediction. Once the model is trained on the training set, we use it to predict the value with the test data. Okay, and before that, let me just have a view of that in a scatter plot. Kindly just observe. Okay, here we just have it. Okay, now let me just compute the accuracy, and of course mean square error, R squared and adjusted R squared, that we are just going to calculate it, and here we have the tabulated manner. Okay, one thing observed, dear friends, the R squared value of this, here it is by using OLS model, it is 0.86. When on just making it towards this SGD, we just get 0.71. So it's not uncommon for ordinary least square method to outperform the stochastic gradient descent approach in terms of accuracy measures. Now, actually coming towards this both tabulation and to the resulted model, yes, here we just get OLS is performing better than SGD. Yes, the exact OLS model's performance metrics like R square, MSC and adjusted indicates that it fits the training data well, capturing the underlying patterns effectively. And towards this SGD, yeah, it just provides a good approximation. It may not reach the same level of accuracy as OLS, particularly if the parameters are not optimal set. So when to use OLS? So when the data set is manageable in size and the computational resources are not a limiting factor, of course, OLS is typically preferred for its accuracy and easy of interpretation. So when I can go for SGD, of course, in case where the data set is too large to fit into memory or when real-time prediction are needed, SGD can be a better choice despite its potential lower accuracy. Okay, now again coming to one point, even though if I just use where this SGD is there, if I just get a performance as like comparing towards here, a lower performance, how I can improve the performance of this SGD model? Yes, dear friends, there are three important things are there. Here I just specify it here. So first of all, where you can just specify, it is all about hyperparameter. Okay, so yes, hyperparameter tuning, experimenting with different learning rate, batch size and iteration. So that are all the exact hyperparameter you can use to improvise the performance. And next, of course, you can just go for future scaling. So here also ensuring all futures are properly scaled. As SGD is sensitive to the scale of the future, so kindly just check whether all futures are scaled or not. And last but not least, it is all about regularization. Okay, so incorporating the techniques like L1 and or L2. So here, of course, I have to specify regularization L1 and L2. This help improve the model generalization. So by carefully analyzing the result and refining the model, you can ensure that you are making the most informed decision regarding your predictive analytics. And yeah, dear friends, we are at the end of this project. Yeah, by developing an accurate and actionable regression model for predicting vehicle mileage, this project not only demonstrates the potential of machine learning in enhancing vehicle performance insights, but also underscores its broader applicability in operational efficiency across the automotive sectors. So yes, with a strong commitment to utilize machine learning effectively, automotive companies can bridge the gap between this machine learning potentially and its practical applications. That is setting the stage for more innovative, sustainable and customer-centered strategies in the industry. And yeah, dear friends, I think you like this video. If you found this video helpful, don't forget to hit the like button. And if you not yet subscribed, yes, kindly, dear friends, subscribe the channel and turn on the notifications so you don't miss any of my upcoming content. And dear friends, if you're having any command, so drop me a comment below. So if you have any suggestions or questions for current topic or for future topic, yeah, it would be invitable. And as always, keep learning and stay curious. See you in next video, dear friends. Happy learning.